Welcome to Efiwe, excellence without stress.
Hi guys, welcome back to Efiwe, excellent without stress. So today we'll be going on another topic, and the topic that we will be checking today is variation. Variation is also one of the important topics in which we need to cover as far as JAMB is concerned. But variation is one of the simple topic that we have to treat. What is a variation? Variation is just dealing with the relationship between two or more quantities and how they relate with each other. So now we are going to types of variation. We have mainly four types of variation, which are direct variation, inverse variation, joint variation, and partial variation. So we take this type of variation one after the other and we check how they function, and we form some jump question on it, and we'll see how easy we can actually work with variation. So the first in which that we are going to check is direct variation. If y is directly proportional to x, then we can actually represent it with this. So obviously the sign is actually written sometimes as this: x varies as y, or we say y varies as x. So you can see that variation sign looks like a fish, but we are you can see that variation sign looks like a fish. So here we say that y varies as x. Then if we want to check the quantity between, or the relationship between y and x, then we come up with the introduction of a constant, and that is why we have y equals to k x. So when anytime we are dealing with variation, we should have it in mind that the variation sign always change to equal sign, but it can only change up to equal sign, but it can only change to equal sign if we have a constant. So a constant makes the quantity between x and y to be equal. So that is how we illustrate a direct variation. Now back to the next one, which is inverse variation. If y is inversely proportional to x, then it is written as this, and that is what we have shown you here. It is written as this. So y varies 1 over x. So from the word inverse, that is why we have 1 over x. So if we are to introduce constants to make the quantity between x and y to balance, then we have to introduce k. So anytime we are introducing k, we have where k is constant to show where k is coming from. Now we also have a joint variation. This joint variation involves two or more quantity. That's why we call it joint. We don't relate two quantities, we relate more quantities together. We have two or more quantities. That's why we call it joint variation. So the quantity can be 3, it can be 4, it can be 5, depending on how it is presented to us. But here we are just relating 3 quantities together. That is why we have a joint variation. That is why we put it as if y is inversely proportional to x and variatory proportional to z. Then it can be written as this. As you have seen on your screen here, we have y varies inversely as x and varies directly as z. So if we should join the two quantities together, which is the inverse and the quantity z, we are going to have a y varies as z and inversely as x, which is the same illustration. So to make our equal sign stand, then we have to introduce k, what we call constants. You can use any variable to represent your constant, but it must be shown that the variable that you are using is actually a constant. Sometimes we might have y varies directly as x and vary directly as z, or be it in any other form. So which means that we don't have to have this inverse here. So we say that y equals to xz if we don't have inverse in our question. And we have the last one, which is partial variation. If y is partly constant and partly varies as x, then we can illustrate it as this. Our y is partly constant here, which is equal to the first constant, which is partially constant, and the second constant the second constant is introduced to the second variable. So we use k and c to introduce our constant here. So most of the time our partial variation normally deals with two constants, and that involves that we are to solve most of the time simultaneously if one variable, if we are not asked to get one variable in terms of the other. So let's try and check some question related to this type of fraction that I have tried to introduce. So here we have the first question. If x varies directly as the square root of n, and x equals 9 when n equals to 9, find the value of x when n equals 1 whole number 7 over 9. You see that the first two values were given, which is x equals to 9 when n equals to 9, and we are still have to find the value of x again when n equals to 1 whole number 7 over 9. So in this situation, the first two value is what we use to get the constant that we introduce, because we must be able to get the k that we introduce before we can move further to variation question. So here we have x varies directly as the square root of n. So we have the square root. This x, which is the quantity here, varies as the square root of this guy here. So that's why we have it like this. So we are going to introduce k, and you should know that eventually when we introduce k, our variation sign changes to equal sign. So that is why we have our k there as a constant. So we substitute the first value that we are given, which is x equals to 9 when n equals to 9. So we have the same value for it. So which means that we are going to substitute it inside this place. So that's why we have it here. X equals to 9 when n equals to 9, given from the question. So we have our x to be equal to 9, we substitute, and we have n to be equal to 9. So square root of 9 gives us 3. So that's where we have 3k here. So obviously we divide both sides by 3, and at the end of the day we have k to be equal to 3. So that is the first part, which is the constant. So whenever you are given a variation question, the first thing you look out for is to solve for the value of the constant that you use in representing the variation. So which means that here we've gotten our value for k to be 3, and then we are going to write the relationship between the two quantities out, and that is from this. So we substitute our k alone, and that is where we get the relationship. So here now we are asked to find the value of x when n equals 1 whole number 7 over 9. Obviously this is in form of a mixed number, or we call it a mixed fraction. So obviously we are going to change the mixed fraction back to improper fraction for easy solving. So here now we change it back and we get 16 over 9. So we substitute back to our n here in order to get the value of x. So at the end of the day we got the value of x to be 4. So you can see that it's easy to relate with, but one thing about variation question is that you must be able to read the question, understand the question, and interpret the question very well, and you substitute any value that you are given. So let's check the next example that we have. Now obviously this is talking about an inverse variation. So here we have p varies inversely as a cube root of r, and p equals 1 when r equals 8. Obviously we are given the two values to use to get our k, which is p equals 1 and r equals 8. Before we can now find r when p equals 3. So we illustrate the question first before we now proceed. So here we have p varies inversely. So inverse means 1 over a quantity. 1 over a quantity. So here we have p varies inversely as the cube root. Now that is why I've illustrated my cube root like this, as a cube root of r. So you must be careful in any of the variation question. And here we have to introduce our k times all these guy here. Then we have k times 1, which is k all over the cube root of r. That is when our variation sign changes to equality sign. Here we have the first value we have to substitute, which means that we have to substitute the value in order to get our answer. Here we have to substitute the both value in order to get the value of 4k. So here we have p equals 1 and r equals 8. So obviously when I substitute a instead of 8 instead of r, I'm going to have the cube root of 8. So cube root of 8 equals 2. What do I mean by cube root of 8 equals 2? So which means that we are going to get a value in which we are going to multiply 3 times. So far we are talking about cube root. Cube root means 3i's. So which means that we are going to substitute, we are going to look for a value in which when we multiply 3 times, we are going to get 8. So obviously we use 2. 2 can be multiplied 3 times to get 8. So that is why our answer for cube root of 8 is 2. You can also check other values that has cube root. You will see that obviously we are going to get the same answer. Now here we are going to have to cross multiply in order to get the value of our k, and the value of our k at the end of the day is 2, because 2 times 1 gives us 2. The relationship between them, we are going to rewrite our illustration here out, and then we are going to substitute k in order to get the relationship between the two quantities. So here now we have the relationship between them, so which means that if there is 2, it makes the quantity for p and this guy here to be equal to each other. So now we find the value of r that we have to do. Find the value of r when p equals 3. So how do we do that? So we bring this one back, or we use the relationship. So the relationship is p equals to 2 over cube root of r. So that's what we have here, and we substituted 3 here. So when we substituted 3 for p here, we have 3 equals 2 over cube root of r. So we try to make cube root of r the solvable formula. That is why we have a cube root of r equals to, we divide both side here anyway, we divide both side here by 3. So that's why we have cube root of r to be equals to 2 divided by 3, and at the end of the day we cube root both sides so that the cube root can cancel cube here. So that's why we have r to be equals to 8 over 27. So I hope that is clear to us, because these 3 will affect everything, both numerator and denominator inside this bracket. So I believe it's very clear to us, and we can try some question on inverse variation ourselves. So now we are going to the next 3 quantities as well, and let's see how this question goes. So y varies inversely as square of x, and x varies directly as square of z. Find the relationship between y and z if c is a constant. So specifically we have been given that c here is a constant, and we have been we are told to relate 1 or 2 things together. So we are going to try and illustrate the question and manipulate it out, and if you know that you can try, you can pause the video and try it on your own. But for what we have here, we have y varies inversely as the square of x, and this is the first illustration about that, because we talk about inverse, and x varies directly as the square of z. So that's the second illustration. And now what we try to do here is that anywhere where there is x, we put z square. So which means that this x here can be equals to k, which means that this x here can be illustrated as z square. So here now I put I substitute the x here. So here now when I try to actually manipulate, and I've been given that c is a constant, so it makes it easier for me to actually do something like that. So when I substitute my x here, which is z square, I have z raised to power 4 here, and I change it to equal sign, and I've been able to substitute my c back. See, these are the type of questions that JAMB can ask from us, and once you watch this video, you will be familiar with JAMB question, and you'll be able to actually solve them. So let's go to the second part, with which is partial variation. So how do we go with this partial variation? Obviously, let's check this question very well. You can pause it and go through it one after the other, and I believe at the end of the day you should be able to solve it. But now before we go, we have the quantity y is partially constant and partly varies inversely as the square of x, not at the square root, but as the square of x. So how do we illustrate that? So we say that y is partly constant. If y is partly constant, so we introduce two constants for partial variation, and this is how partial variation question normally looks like. So here we have y is partly constant and partly varies inversely. Now that's why we have 1 over x squared here as the square of x. So we put our c and k, which are the constant here, and we substitute the first value in order to get our constant. Obviously our constant here is 2. That shows that the value that will be given to us will be in 2 pairs, so that we can form a simultaneous equation on it, because we have two variables. So anytime we are having two variables, we have to get the values in which we can use to form a simultaneous equation and be able to get the constant value, which is c and k. So when x from the b now, when x equals to 1, y equals to 11, and when x equals to 2, y equals to 5. So we substituted these values and we have it here. This is the first equation. We use this one to generate a second equation. So when we combine the both equations, we use simultaneous equation method. And under simultaneous equation method, you can use is either substitution or elimination method. So you can either use either of the two to actually provide answer here. So here we now have something like this. At the end of the day, we got our c to be 3 and our k to be 8. So which means that we can actually substitute c and k in our question here. So which means that we can get a relationship between y and x, and that is what we have done here. So when we have it here, so obviously we can find the value of y when x equals to 4. So which means that we have to substitute the value of x here, which is 4, and try to manipulate it, and at the end of the day we get y to be equals to 3 whole number 1 over 2. So which makes the question to be simple. We've gotten the relationship, and we've gotten the value of y. So I hope this is clear, and we've been able to enjoy what we have here.